Alright, today we're going to talk about graphing linear inequalities. Your essential questions for today are: can you use addition, subtraction, multiplication, and division to solve inequalities? Can you graph the solution of a linear inequality? And can you write and solve a linear inequality that represents a real-world problem? So first we're going to talk about what a linear inequality is. And it is simply an equation of a line and instead of it being with an equal sign, it's going to be using less than, greater than, less than or equal to, or greater than or equal to sign. So linear inequalities can be written using these four symbols, and if it's written in slope-intercept form, it would look like y is less than or equal to mx plus b. If it's written in standard form, it will look like ax plus by is less than or equal to c. And each of these inequality symbols are interchangeable with any of the other three. So first we're going to see if we can tell whether an ordered pair is the solution of an inequality. In the first problem, we're given an x value and a y value. So we're going to fill those in for x and y and decide if the inequality is true. So 2 times -1 is -2, plus 9 is less than -3. -2 plus 9 is 7. 7 is not less than -3, so no is my answer for that first one. On the second one, we're again going to fill in our x and y values. So 2 minus 3 times -2 is -6. And then I bring down my greater than or equal to 8. 2 plus 6 is 8. 8 is equal to 8, which we have here. So yes, 2 -2 is a solution of this inequality. And finally, I'm going to fill in x and y. -2 plus 2 is greater than 0. Well, 0 is not greater than 0, so no, -2 is not a solution of that inequality. We're going to talk about graphing linear inequalities, and the first step to graphing a linear inequality is to graph the boundary line, or just graph the line that you're given. So let's write that down. Graph the line. Now, if you have a less than or greater than symbol, the line will be dashed, because it doesn't actually equal, so the line has to be dashed. But if we have less than or equal to or greater than or equal to, we're going to graph it with a solid line. The next step is to test a point. To see where we're going to shade. We'll talk more about that in a minute when I do an example. And the last step is to shade the correct portion of the graph. Alright, so all in all, graphing a linear inequality is extremely similar to graphing a linear equation. All that's different is when you look at it, you have an inequality instead of an equal sign. And then we have to do a couple extra things to graph it correctly. But when you graph the line, it's the same exact process. So turn your paper over. Let's try a couple of examples. The first one says, graph y is less than 2 in a coordinate plane. So I need to draw my coordinate plane. I'm going to graph the equation y equals 2. So y always equals 2. And because this is an equal sign, this is a solid line. Now my second step was to test a point. So I'm going to test 0, 0 because it's always easiest. So if I fill in 0 for y, if y equals 0, is 0 less than 2? Yes, of course it is. So that is a solution to my inequality. So I know that everything below my line is going to be shaded in. I didn't do a great job of shading, but you get the picture. On the second one, x is greater than 1. If I graph that, I don't have an equal sign, so I have to have a dashed line here at x is 1. And I'm going to test my origin again, 0, fill in 0. Is 0 greater than 1? No. So I know I don't want to shade that section. So I shade everything over here. Now, we can also use logic and common sense to see if these make sense. Y is less than 2. Well, here's everything less than 2. X is greater than 1. All of these numbers are going to be greater than 1. So they do make sense in a logical way. Let's try some more difficult ones. I would first change these into slope-intercept form, which of course means I need it to say y equals. So I'm going to add x to both sides and divide everything by 2. And I get y is greater than 1/2 x plus 1. This is 1/2 x. 2 divided by 2 is plus 1. So if I graph this, I'm starting at 1, going up 1 over 2, up 1 over 2. And I know that I have a dashed line because I have no equal sign. And let's see, logically, y is greater. So here are the greater y's above. But let's test a point. Let's say x is 0, y is 10. So if x is 0, 0 plus 1 is 1. And y is 10, 10 is greater than 1. That's true. So I know that I want to shade above the line. On the next one, I'm going to change it to slope-intercept again. Subtract 2x from both sides. Divide by 2. So y is less than or equal to -1x plus 3/2. So I start at 1 1/2. I'm going down 1, right 1. And I have an equal sign here, so I'm going to have a solid line. And I know that y is less than, so I'm going to shade everything below my line because that's where less than would live. Alright, on to the real world problem. You can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound, and apples cost $1 per pound. So to rate an inequality, you need to have $2.50 per pound for grapes, plus $1 per pound for apples. And the most we can spend, so we can spend less than or equal to $10. So now, if I want to make this, say y equals, I would subtract 2.50g, we'll call this x's, and we'll call this y's. Divide by 1. So y is less than or equal to negative 2.5x plus 10. A negative 2.5 written as a fraction so that I can find my slope easier would be negative 5/1. So to graph this, I start at 10, going down 5/1, down 5/1. I know I have an equal sign, so I have a solid line. Now we need to identify and interpret two solutions of the inequality. So two solutions of this inequality, I guess we didn't really have to change this over. We could have left it as 2.5g plus 1a is less than or equal to 10. You can choose any solutions here. You could say, okay, I can get 2 pounds of grapes. That would cost me $5. So then I could get 5 pounds of apples. And that would be $10. I could just get 8 pounds of apples. That would be less than $10. I could get 1 pound of grapes and 1 pound of apples. That would be less than $10. So the number of solutions that we have here, there's a whole bunch of them. And you can choose any two that you want to answer these questions. So these types of answers are really open-ended and there are lots of possibilities. One of the safest ones is normally 1 pound of each item is going to come in under the price tag. Or 10 pounds of apples, or 4 pounds of grapes. So you can identify any two solutions that you'd like. Alright, I have 5 practice problems for you to do for your homework assignment, and I will see you in the morning.